Hi students, myself Dr. J.P. Sridhar, Associate Professor, Department of Electrical Engineering, SJBIT. Today we can discuss important topic that is characteristics of DC motors. Characteristics of DC motor. Characteristics of DC motor. Whether it is a shunt motor or a series motor, there are three important characteristics. Okay. As we know already, that in the classification we classify the DC motor as DC shunt motor, DC series motor as well as compound motor based on how field winding is connected across the armature circuit. So coming to the characteristics of DC motor, now we are considering shunt motor. So first I will take characteristics of DC shunt motor. There are two characteristics which are called as electrical characteristics and one characteristic is called as mechanical characteristics. First I will take electrical characteristics, that is armature current versus armature torque, that is TA versus Ia, that is armature torque versus armature current characteristics. It is also called as electrical characteristics. It is also called as electrical characteristics. And second characteristics is also electrical, that is called as speed versus armature current characteristics. Speed versus armature current characteristics. These two are called as electrical characteristics. And third characteristic is called as mechanical characteristics, that is called as speed versus armature torque. Speed versus armature torque, both are related in rotation, mechanical rotation, so therefore it is called as mechanical characteristics. Okay, so these are the three important characteristics. Whether it is a shunt motor or series motor, we will explain these characteristics in the coming slide. So before starting that, first characteristic, that is armature torque versus armature current, I will draw the shunt motor, okay, for the understanding purpose. I will write the DC shunt motor. You can observe now load is connected here. It is understood, load is connected. So input is electrical energy, that is V, and this line current is flowing at this node. Because it is a shunt motor, so field winding is connected parallelly across the armature. This is called as shunt current and the resistance is called as RSH, and the back EMF is produced, that is EB, and the current flows through the armature circuit is IA. Okay, so we know that in DC shunt motor, so what is the back EMF equation? Here we can take now torque equation. It contains even armature current. So what is the torque equation of DC shunt motor? 0.159 flux pi Ia PZ by A. Okay, so this is the DC shunt generally torque equation of DC motor. Here you can assume the shunt motor, okay, the voltage applied is voltage applied is constant, hence the current flows to the field winding is also a constant. So the flux pi is constant in case of shunt motor because V is constant. Because of this V is constant, even ISH is also constant. This is constant and this is fixed, pole is fixed and armature conductors are fixed. Hence in DC shunt motor, TA is proportional to flux Ia. TA is proportional to flux Ia. And what is my ISH? ISH is V by RSH. This V is constant. Okay. And what is Ia? IL minus ISH. And we know EB, that is back EMF, is V minus Ia into RA plus V brush if it is given in the problem. Okay. Now, so because of this constant in nature, okay, I can draw the characteristics like this. So armature current versus torque, that is armature torque. Okay, as current increases, because Ia is proportional to TA, as current increases, even torque also increases. Okay, I will write like this. This is called as armature torque. Now I will write one more torque called as shaft torque, which is less than the armature torque. I will represent this as TSH. Why this TSH is less than the armature torque? Because of the losses due to mechanical vibrations in the machine. So this is called as TL, that is load torque. The difference between the armature torque and the TSH is called the TL. TL is called the load torque. So we can keep it in mind. The shaft torque is always less than the armature torque due to iron losses and mechanical losses of the DC shunt motor. So hence it is, we can show always TSH value is less than the armature torque. So from this we can come to know that generally because of the voltage remains constant, the shunt motor speed is also remaining constant. Okay, so therefore, so the speed is running almost constant in case of shunt motor. Coming to second one, that is speed versus armature current. Speed versus armature current. Now I will take back EMF equation. EB is equal to Zn pi by 60 into P by A. So for the given machine, these are all the constant. So in that shunt motor also flux is also constant. So therefore N is proportional to EB divided by flux. Okay, the flux is also constant in case of shunt machine. Therefore N is proportional to EB. Why it is constant? Because shunt motor, the voltage applied is constant, hence flux also remains constant. So remaining thing is N is proportional to EB. So what is EB? Voltage equation V minus Ia RA. Therefore N is proportional to EB minus EB is proportional to V minus Ia into RA. So from this we can write the characteristics. I will write it here. Okay, you can observe in this page only I will write, I will understand purpose. I will write N. This is armature. In previous case also I will take armature current in x-axis, and here speed I will take it in y-axis. In previous case I will take torque in y-axis 0. What happened, I can imagine initially when armature current is 0, the motor will be at rest condition. As soon as the current, armature current flowing to the motor, the speed starts, okay, rotating, the starts takes place. This is general no load speed, and due to less armature drop, okay, so IARA is the armature drop, the speed is little bit decreasing from the reference speed, that is N0. So as IA increases, IARA drop also increases, but this IARA drop is negligible as compared to supply voltage, because this IARA, because of the resistance of the armature is very small. Okay, the drop across armature is very small as compared to supply voltage. Hence in case of DC shunt motor, because of less drop in the armature, the motor speed not much decreases, it remains run in almost constant condition, and this kind of motors will be employed for constant speed operation. Okay, thank you. With this I'll conclude my video.